Hi Year 12, work for Tuesday, week 10. It's Monday when I'm doing this. It's got some beautiful rain out here today. I hope you can see that board with no glare. Alright, just a couple of things for you. Make sure your calculator's in radians mode, just saying that again. And have Desmos ready, will you please? If you haven't charged that up, make sure you've got it. You're going to really need to do some of these things as curves on Desmos. Alright, we're doing 6C. Question 3, which is all the trig calculus application, so drawing and gradients and tangents and all that sort of stuff. So this one says, find the equation of the tangent to x sine x. Yeah, it's a product, so you're going to have to do something with that, at the point pi, comma, 0. So, x sine x, vu dash plus uv dash gives you sine 1 x cos x, which means that the y dash is sine x plus x cos x. Pretty straightforward. So, gradient of the tangent at x equals pi, sine of pi is 0, and then pi times cos of pi, which is minus 1. So the gradient of the tangent is minus pi. Now, y minus y1 equals mx minus x1 for your equation of your tangent. So y minus 0 equals minus pi, x minus pi. So it's y equals minus pi x plus pi squared. Pretty straightforward, and again, if you had to go the extra step to do the gradient of the normal, you would flip that over so that your gradient of the normal would be, 1 on pi. You haven't been asked that there, but that's coming in some of the other questions. Alright, question 8. It says y equals e to the power of cos x. Don't panic. Y dash is just the function dash x, e to the function x, so bring the derivative down, so it's minus sine x, e to the cos x. That's pretty straightforward. And then it says find the tangent, find where the tangent is horizontal, or horizontal tangent just means turning points. So 0, 2 pi, so minus sine x e to the cos x, this bit can never be 0, e to the power of anything, never 0. So where is minus sine x equal to 0? Well, let's draw minus sine x. So the gradient of the tangent there is 0 at 0, pi and 2 pi. Pretty straightforward. Alright, question 11 is hard. You might want to replay this over and over and over. So it says y equals x plus sine x. It's the curve we're going to draw. You're going to draw it on Desmos as well. Find y dash, 1 plus cos x. Find y double dash, minus sine x. Now it says in between the boundary minus 2 pi and 2 pi. Stationary points at y dash equals 0. 1 plus cos x equals 0, which means cos x equals minus 1. So I drew cos x, worked out where it was minus 1. It's down here. So that's at pi and minus pi. So your stationary points are pi, chuck it back in, you get pi. Minus pi, chuck it back in, you get minus pi. So they're your two stationary points. Be careful, that doesn't mean they're maximums or minimums. We'll get to that bit in a minute. I'm going to do that nature bit in a minute. Now, inflection points. Y double dash equals 0, so minus sine x equals 0. Draw minus sine x between minus pi and 2 pi. You can see that it's 0 there. Now it's also 0 there and there, but this thing said between minus 2 pi and 2 pi, so I've only got to find that one. So, inflection point at 0. Chuck 0 back in there and you get 0. So 0, 0 is an inflection point. Now, just before we go any further, have a look. We had these other stationary points at pi, comma pi, and minus pi, comma minus pi. How are we going to draw this? We need to find the nature of these turning points. So your nature of the turning points, check out y double dash. Oops, that should be y double dash in there. So at x equals pi, y double dash gives you 0. And at x equals minus pi, y double dash gives you 0. So it's not greater than 0 or less than 0 for a maximum or minimum. It ends up being 0, which means they're not maximums or minimums, they're horizontal points of inflection. So you've got inflection there, horizontal inflection there, horizontal inflection there. What is this going to look like? No turning points, so it's going to go, I can't really draw it very well, you'll be better on Desmos. So that's what y equals x plus sine x looks like. Now, if I just take you back to one we did quite a few weeks ago where we did x plus 1 on x, do you remember what that looked like? Remember it was like that and like that? And this 1 on x thing, the x and the 1 on x thing had something to do with there. That's what that x does there, brings it to that line. Alright, I hope that's not too tricky. That's a really hard one. Take your time and have a look at it over and over again. Have a good day.